Hi, Rockstars. We will be kickstarting a wonderful series on chemistry. We will be kickstarting our chemistry ignition series. Listen, if you ever had problem with chemistry, stay with me. That story is about to automatically change. We will be starting up with introduction to chemistry under nature of matter. Under this topic, we will be introducing the concept of matter, under which we will define matter, talk about the states of matter and its conversion. We will advance to talk about the properties of matter, physical and chemical change, and we will then talk about elements, compound, and mixture. Then we will be at the end using this knowledge to crush UTME questions. Stay with me. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to smash the subscribe button, turn on the notifications. Let's get started. Matter, a very important concept in physical science. Matter is anything that has mass and can occupy space. Please take note, not anything that has weight, but anything that has mass and can occupy space. Because there is difference between mass and weight that I have treated in physics ignition series. So you can do well to search and watch and learn from that. So now the states of matter. Now from the definition of matter, it's clear that almost everything found in the universe are made up of matter, be it if they are in different states. And matter is made up of atoms, molecules, or even ions. Now, the states of matter can exist in three main states. Number one, it can exist as a solid where the molecules are tightly bound together. Number two, we have liquid. Now, in this, the force of attraction, that means the space between the molecules are loosely packed compared to that of solid. So they are flowable. So you can call them fluids. So they are flowable. So liquid, they do not have a definite shape like solid. They take the shape of the container that they are in. They have a definite volume. Now, and lastly, we have gaseous state. They are loosely bound together. The molecules are free compared to liquid and compared to solid. So they have high level of entropy, high level of randomness or disorderliness, as explained by Brownian motion. So liquid and gas are collectively known as fluid. So these are the three states of matter. And now there is tendency for a matter to change state among these three states here. Now, when solid changes to liquid or to gas. Now, when solid changes to liquid, for instance, ice block melting to liquid. So it is called what? Melting. When liquid changes to gas, like while cooking, the liquid changes to steam, as in water. We call that vaporization or evaporation. These two are very related terms, where liquid changes to gas, but they are different. Evaporation happens at all temperature, but vaporization always happens at boiling point. Evaporation is a surface phenomenon, whereas vaporization is an integral phenomenon. So they are different, but they are all change of state from liquid to gas. Now, when liquid changes to solid, like our liquid water changing to ice block, we call that what? Freezing. It loses heat and becomes ice block. Now, when gas changes to liquid, we call that condensation. Like the rainfall. Condensation. Now, there are states, there are scenarios where solid changes directly to gas without passing through the liquid state, or gas changing directly to solid without passing through the liquid state. We call that phenomenon sublimation. So, example of substance that can sublime are our ammonium chloride, our camphor, our solid iodine. They change directly from solid to gas without passing through the liquid state. So that these are states of matter and its conversion. Now please take note that some matter are at a particular state at room temperature. For example, stones are solid at room temperature. Gold is solid at room temperature, but by the application of heat, it can melt to liquid. Our water is liquid at room temperature, but can be solidified into ice block and can be heated into what? Vapor. That's steam. And our oxygen, our carbon 4 oxide, our carbon monoxide, our nitrogen, they are what? They are gas. They are gaseous in or at room temperature. So now let's advance and talk about the properties of matter. The properties of matter. Now, matter are known by certain characteristics they portray, and that characteristic is termed property. And property of a matter can either be physical, relating to physical changes, or chemical, relating to chemical changes. So we have two types of changes based on the property of matter. The changes can be physical change and it can be chemical change. So physical change or changes are those changes that are easily reversible and no new substance are formed. That means in a physical change, you can bring it back to the former state. That means you can convert the product back to the reactant and nothing new actually is formed. Now, for instance, one classical example of physical change is change of matter, as I have explained previously. Let's say, for example, our ice block, that's our water at solid state, changes to our water in liquid state. Now, this changing to this is what? Is our melting, when we apply heat to it. Now, nothing new is formed. This is water, this is also water, and I can reverse it from liquid back to solid by refrigeration, freezing. So this is a physical change. Another example is dissolving or dissolution of sodium chloride in water. That's our salt. When you dissolve salt in water, you will get what? Your salt solution. Nothing new is formed because in the salt solution is your salt and your water. The solvent and the solute joining together to form a solution. I can reverse this back by what? Evaporation. I will heat this solution, the water will evaporate, leaving the salt. So I can reverse it. Nothing new is formed. These are physical change or changes. Now for chemical changes are changes that are not easily reversible and new substances are formed. You see, so in chemical changes, the reactant is different from that of the product, and you cannot easily convert the product back to the reactant. For instance, all forms of burning or combustion are mostly chemical change. For example, my wood plus, let me say I burn plus fire, it will give me ashes plus gases. Now take note, this is my reactant at my left hand side, these are my products at my right hand side. This is something new because wood and ashes, they are completely different in terms of structure and in terms of chemical composition. They are different, and I cannot easily convert ashes back to wood. So this is a chemical change. So note, every form of burning of fossil fuels, burning of wood, burning of paper, they are chemical change. Even consumption of food that you eat, the food changes into something else, your feces. You cannot convert that feces back to the food you ate. And the feces is different from the food you ate in terms of structure and chemical composition. Also, rusting is a good example of chemical change. Now, our iron, which is Fe, in the presence of water and air, oxygen, produce what we call iron rust, which is a hydrated form of iron 3 oxide. That's Fe2O3. This is iron rust. So the iron is different from the iron rust. The iron is strong. The iron rust is flaky. So you cannot convert this rust easily back to the iron. And the iron is different from the iron rust. So something new is formed and it is not easily reversible. So physical changes can easily be reversed and nothing new is formed. The product and the reactant are still same, but just in different states or form. But chemical changes, the reactant and the product are completely different and you cannot easily reverse it back. Now, let's advance to talk about elements, compounds, and mixture. Now, element is any substance that cannot be split into simpler form by ordinary chemical reaction. Now, we have more than hundreds of elements, but elements are grouped into 3 major classes. They can be metals. That means whenever they are engaged in a reaction, they are always the givers. They are always the donors of electrons. So they are electron donors. Or they can be non-metals. whenever involved in a reaction, they always accept electrons, and also they are bad conductor of electricity or even insulators. Whereas metal, they are good conductors of heat and electricity. And we have an intermediate of these two. We call that one metalloid, or you can also call it semi-metal or semiconductors. Now, other metals, as we will discuss in detail in periodic table, other metals, elements that fall under group 1, the sodium, the potassium, the calcium, the lithium, element in group 2, the magnesium, the calcium, the beryllium, elements in group 3, the aluminium, fall under this group called metals. So under this we have group 1 to 3, mainly, and also the transition metals, the transition elements, the transition metals. Then we have our non-metals. Our non-metals starts from our group 5, our nitrogen family, our group 6, our oxygen sulfur family, our group 7, our halogens, fluorine, chlorine, bromine, iodine. They fall under this class known as the non-metal, and even possibly our group 8, which is the noble gas. So from group 5 down to group 8, they are non-metals. Then we have our metalloids, or semi-metals, or semiconductors, that falls in between the metals and the non-metals. Under this we have our group 4, the carbon family. We have our silicon, our germanium. We use this one as semiconductors as our group 4 elements. So these are the major classes of elements. When we advance to periodic table, we will see them in different blocks: the S block, the P block, the D block, the F block. So these are the classes of metal. It's very expedient as a chemistry student to make sure you master, at least know your first 20 elements. Very important. And I will be making a video of how you can easily master your first 20 elements without stress. And you can also advance to master from your 20 to 30. Very important because of they involve the transition elements. So it's important you have mastery of your elements. Elements are the backbone of chemistry. It is very important you know the elements. If you falter in this area of the foundation of the building of chemistry, I bet you your chemistry will be like hell. So it's very important you take this moment to master your elements. Now let's move on to compound. Now, compounds are formed when 2 or more elements are chemically combined together. So it's important you put that word chemically combined together. So now, for instance, when I react hydrogen plus oxygen, it gives me water. So this is an element, another element, combined together chemically, they give me a compound known as what? Water. When I combine sodium plus chlorine, it gives me sodium chloride. You see it? When I combine carbon plus oxygen, it gives me either carbon monoxide or carbon oxide or carbon dioxide. You see, so these are compounds formed when 2 or more elements are chemically combined together. So it can be more than 2. For example, we have calcium plus oxygen plus carbon. You get calcium carbonate. It can even be 4, like calcium hydrogen triisocarbonate. So you see, compounds are formed when elements, 2 or more elements, are chemically combined together. Now, lastly, we have mixtures are formed when 2 or more constituents are physically combined together. So you see, compound is 2 or more elements. Mixture is 2 or more constituents. This constituent can be compound, element, or compound element. So, and for compound, they must be chemically combined together. Compound C, chemical C, combined together. But for mixture, they are physically combined together. And that's the reason why in separation techniques that we will see in our next class, you will notice that these mixtures can be separated by physical means. Compounds can be represented with a chemical formula, but mixture cannot be represented with a chemical formula. So example of mixture is urine. Urine does not have any formula. Urine is composed of urea, bilirubin, sodium chloride, water, ions, electrolytes. So you see, there are a lot, both elements and compounds, that makes up urine. So, but urea now, that is one of the components of urine, has a formula. Urea has a formula. Sodium chloride has a formula. Water that is found in urine has a formula. So, urine is a mixture, urea is a compound. Another example, our air is a mixture. So what we define air as? Air is a mixture of what? Gases. Inside air, we have nitrogen, we have oxygen, we have carbon dioxide, we have noble gases like argon. This about 78%, this about 21%, this about 0.03 to 0.04%, this about 1%. So all, both elements and compounds, make up air. So air is a mixture. Another example of mixture is our bones. Bones is made up of copper and tin and brass. Brass is made up of copper and zinc. Very important, damn like asking questions from this corridor. Bronze, copper and tin, brass, copper and zinc. It's expedient you master the difference between compounds and mixtures. So now can we go and crush UTME questions? Come with me. Okay, the first question. The process whereby a gaseous body loses some of its kinetic energy to a colder body is referred to as condensation, melting, evaporation, and freezing. Now, remember from what we talked about in change of state, this question is set to assess the student's knowledge of change of state. A gaseous body losing some of its kinetic energy to a colder body, gas. Our answer is what? Condensation. A phenomenon whereby a gaseous body loses heat to a colder body, thereby there is a decrease in its kinetic energy, so it changes from gases to what? Liquid. Let's move to the next question. This one is a bit long. A mixture is different from a compound because, so this is trying to assess our knowledge about the differences between compound and mixture. So let's go. But the constituents of a compound are chemically combined together, while those of a mixture are not. Remember, we said this while we were differentiating between the both of them. We said compounds are chemically combined together, compound C, chemical C, whereas mixture are physically combined together. So this A is correct. The B says a mixture is always homogeneous while a compound is not. This statement is not correct because compounds are homogeneous always, but mixtures can either be homogeneous or heterogeneous. So when all the components are in the same phase, it is homogeneous, but if they are in different states in that solution, it is heterogeneous mixture. So B is wrong. C, a mixture can be represented by a chemical formula while a compound cannot. They interchanged it. Compound that can be represented with a chemical formula, whereas a mixture cannot. Lastly, the properties of a compound are those of its individual constituents, while those of a mixture differ from its components, from its constituents. They also interchange this one. So the components of a compound, they lose their individuality when forming that compound. That means the individual property differs from the property of the compound, but in mixture, they still retain their property. So this statement is wrong. So the only correct answer is what? A. Constituents of a compound are chemically combined together, whereas mixtures are not. They are physically combined together. Now let's move to the next question. Okay, the third question. Which of the following is a physical change? Remember, we said physical changes are easily reversible and no new substance are formed. A. Freezing of ice cream, dissolving calcium in water, burning of kerosene, exposing white phosphorus to air. So it's very obvious that our answer is freezing ice cream. Every change of states are physical changes. So freezing of ice cream is the answer. Now, why are the others not the answers? Dissolving calcium in water. When you place calcium in water, it sinks and begins to bubble, releasing hydrogen gas. We call it like flaking of lime. The water becomes milky because of the formation of calcium hydroxide. So that's a chemical change. Burning of kerosene, I told you any burning are chemical changes. So burning of kerosene is a chemical change. Exposing white phosphorus in air. Okay, now this is a unique kind of chemical reaction that happens whenever you expose white phosphorus to air. It's actually dangerous because it becomes very inflammable. When you expose phosphorus to air, which is oxygen, it releases instant fire, forming phosphorus 5-oxide. So this is a chemical change. So our answer is freezing ice cream. Let's go to the next question. So the next question, which of the following is an example of a mixture? Blood, sand, washing soda, common salt. Remember, we said mixtures cannot be represented by chemical formulas, whereas compound can. So blood is actually a mixture comprising of a lot, ranging from food nutrients, water, electrolytes, urea, many things. So this is definitely a mixture, and this is our answer. A. Sand is not a mixture. Soil is a mixture. Silicon dioxide, that's the formula for sand, so it's a compound. Washing soda is also a compound. That's sodium carbonate. It's a hydrated sodium carbonate with 10 molecules of water. And common salt, I believe we already know that common salt is sodium chloride. So those three are all compounds, whereas blood is a mixture, a body fluid that helps for transport of nutrients and other things. So So A is our answer. Now let's treat the final question. So our final question, because of time. Which of the following is an example of chemical change? Dissolution of salt in water, rusting of iron, melting of ice, separating a mixture by distillation. If you've been in this class, this will be a long question for you. So now, let's assess the question. Dissolving salt in water, the physical change. Rusting of iron, remember we said iron 3 oxide. So this is iron rust. So, and this rust is different from the iron, and you cannot reverse it back. So this is actually a chemical change, which is our answer. Melting of ice, melting, a change of state, a physical change. Separating a mixture by distillation, don't allow it to confuse, it's also a physical change. Remember, I said that separation techniques are mainly physical processes. So our answer is rusting of iron. So in this class today, we've been able to introduce chemistry in the most basic form for easy comprehension and assimilation. So in our next class, we will be advancing to the second section of the introduction, which we'll be talking about separation techniques. You can't afford to miss that class. So please do well to smash that subscribe button, turn on the notification, like, share, comment. I remain your host, Josh White, leaving to catch you another day. Shalom.